Okay, sixth graders, we're going to go through lesson 3.4, and this is on lowest common multiples and greatest common factors of numbers. So we'll have at least two numbers that we're working with, and a lowest common multiple means that we start with some numbers and multiply them out times 1, times 2, times 3, times 4, times 5. These are called the multiples of the number. The multiples of 4. Okay? The multiples of 4 are like counting by 4s. 4, 8, 12, 16, 20, 24. Those are all multiples of 4. Multiples of 10 are taking 10 and multiplying it by 1, and then multiplying it by 2, and so on. So if you're listing the multiples of a number, you are counting by those numbers. Okay? Now, the lowest common multiple is the same number in both lists. So the lowest one that is the same in both lists is 20 in this case. Does that make sense? Does everybody understand what the lowest common multiple means? All right, good. So you count by the numbers, or if you're having trouble counting by the numbers, then you have to multiply them out, or you can continue to add plus 4, plus 4, plus 4, plus 4. Because that's what multiplying is it's adding another number. Okay? Now, sometimes you can find the product of the numbers, and it is the lowest common multiple, especially when one of the products is prime. So, for example, if the numbers are 3 and 14, 3 and 14, one of these numbers is prime. Okay? It doesn't go into the other number. Right? 3 doesn't go into 14. And so the lowest common multiple is going to be the answer to 3 times 14. 42. Okay? So that's one thing that you can remember when you're finding the lowest common multiple. If one of them is prime and it doesn't go into the other number, then you can find it by multiplying the two numbers together. Okay? There's another advanced method that you can use if you want to, and that is to factor the numbers. So 4 is factored using 2 squared, and 10 is factored with 2 and 5. Now, what you do after that is you use the greatest power of each of the prime factors. So, since the greatest power of 2 in the formula is 2 squared, and the greatest power of 5 among our prime factors is just 5 to the first power, then you just multiply 2 squared times 5, and you get 20. That's another way that you can use if you want to. Okay? Let's go on to greatest common factors. Greatest common factors of the number. This is the biggest number that will go into both numbers. So if you're given two numbers, like 12 and 60, to find the greatest common factor, which means the biggest number that goes into both, you can make a factor tree, and then circle the common factors that are prime, circle the prime factors that are common, and multiply one set of common factors. Okay? So let's take this as an example. We factored these out, made a factor tree. Okay? 12 can be factored by using 2 and 6, and then 2 and 3, right? So that's what we did for today. And we can write the prime factorization as 2 squared times 3. Jacob, is this an emergency?
I'm just curious if we have to write these
Oh yes, this is the notes for greatest common factor. Yep, yep. So, to factor out 60, you would write, you could use 2 and 30, because 2 times 30 makes 60. Or you could use 4 and 15, or 5 and 12. But let's say that you start with 2 times 30. 2 is prime, so we have to keep factoring 30. 30 is factored using 5 and 6. And then 6 can be factored using 2 and 3. So, the prime factorization of these numbers is 2 squared times 3 times 5. Let me write this for you again. 2 squared times 3 times 5. Because those are the prime factors that are in 60. And that's what we did for today, right? You all know how to do this much?
Yeah.
So now, to find the common factor, the greatest common factor, you have to find factors that are in both numbers. You circle the factors, the prime factors that are in both numbers. They both have 1, 2, they both have a second 2, and they both have a 3. And then you multiply that out. 2 times 2 times 3 gives us 12. And 12 is the greatest common factor. Okay? So there's a few steps in this one. Let's go through a few of these together, just so you get used to the steps. All right? Make sure that you write down these steps. And I'm going to give you another example. So I'm going to erase this example. And let's do another one together. Let's do this one. Let's see. And 306. Okay? So we have these two numbers. We need to find the greatest common factor. So let's start by factoring 21. How can you make 21?
7 and 3.
Good, 7 and 3. Anything else? These are both prime, right? So we can stop right there and go over to 306. What's 306 divisible by? It's an even number, so 2. 2 times something. Does anyone know? Krista?
153. Knew it.
153? Good. Now, is 153 a prime number?
Yeah. Yeah. No.
Yeah? No? What do we do? It's odd.
No, it's not.
No.
It's odd. So what should we do next? Check. How do we check 3? And come on, people. Always add the digits. When we add the digits, it equals what? 9. So we know it's 3 is a factor, right?
Yeah.
So now we have to divide it by 3. Bella, did you already do that? 51?
Yeah.
Good. Is 51 a prime number?
No. No.
No. Always
Add the digits.
add the digits. It equals 6. That means 3 is another factor of that one. 3 and what?
3 and
Catherine?
17.
17. Very good. Is 17 a prime number? Yes, it is. We can stop. Now, go back, find step 2, and circle the common prime factors. All right? There's a 3 in both, so we're going to use that. Is there a 7 in both? No. Is there a 2 in both?
No.
No.
Is there another 3 in both?
No.
Is there a 17 in both?
No.
That's it. What's the greatest common factor?
3.
3. 3 is the
Oh, that makes
answer.
so much more sense.
Okay?
I knew it. You don't get it?
I don't get
I
it.
don't.
3 is the only number that we could circle in both factor trees. Okay? So 3 is the greatest common factor. If there were others, then we'd have to multiply those together. Alright? Like when we were doing 12 and 60, there were quite a few. There were a 3 and 2 2s. So then we have to multiply those together. Alright, do you want me to do one more of these?
Sure.
No.
Yes.
No. We're
Yes.
good. I'm good.
Yes.
I'm good.
Yes.
One more. Let's do one more. Okay? Sometimes you'll have 3 numbers that you have to factor, find the greatest common factor. Like 20 and 60 and 90. So, let's factor those. I love factoring. 2 and 10, 2 and 5, right? Come on, people.
Those are prime
They're
numbers.
prime numbers, so we'll stop. Let's factor 60. 2 times 30, 2 times 15, 3 times 5. Right?
Yeah.
And let's factor 90. 2 times 45. How do you make 45? 5 times 9. 3 times 3.
Those are prime numbers.
They're all prime numbers.
Correct.
Okay, now circle the common prime numbers. Is there a 2 in every one?
Yes.
Yes, we gotta use the 2. 2 times something. 2 times, is there another 2 in each one?
No.
Nope. Is there a 5 in each one?
Yes.
Yep, there's a 5 in each one. Is there a 3 in each one?
No.
Is there any other numbers in each one?
No.
Because there's only a 2, 2, and a 5 in this one. So the answer is
10.
10 is the greatest common factor.
Woo! Great.
Oh, okay.
Okay? It's really not that complicated once you kind of get used to what you're doing. Okay? Factor all the numbers, circle the common factors, and then multiply them. Okay? Open your books to page 96. 96. Your assignment is on page 96. And it is 14 to 32 evens.